Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Have you ever noticed that the way we talk feels almost like a secret code of physics? Think about the vowels you use every day. Why do high vowels like the E sound in tree and the U sound in true feel shorter when you say them compared to the low vowel a sound in father? That is the mystery we are tackling today. It is widely known in linguistics as intrinsic vowel duration. Scientists have argued for decades about why this happens. Is it just the boring mechanical reality of our mouths, or are there deeper forces at play? For a long time, experts thought this was just a simple byproduct of how our bodies move. They believed that because the jaw has to travel further to open up for a low vowel, like A, that it naturally takes more time to complete the move. Imagine the distance between a high mountain peak and a low valley floor. You reach the peak faster simply because the base is closer to where you started. That is the biomechanical explanation. But some scientists have pushed back. They argue that humans are not just biological robots. We possess something called contrast enhancement. This means we might actually control these tiny details on purpose to make sure people understand us better. If we want to keep our vowel sounds from sounding too blurry, we might stretch out certain ones just to make the contrast stand out more clearly. The researchers in this study wanted to settle this debate by looking at the big picture. They did not just look at a handful of English speakers. They pulled from a massive collection of recordings in over 60 languages from 16 different language families. They wanted to see if this pattern holds up across the entire human experience, or if it is just a quirk of a few specific cultures. What they discovered is fascinating. The high vowels were shorter than low vowels in about 90% of the comparisons they ran. That is a massive trend. It suggests that this is not just a random habit but a statistical universal. It happens almost everywhere we look. But here is where the story gets more nuanced. When they compared high front vowels to high back vowels hoping to find some kind of systematic difference, they found almost nothing. This supports the idea that our sounds are not just random. They are governed by what these researchers call target uniformity. This pressure works like an invisible glue, keeping the timing of similar sounds in the same ballpark, because our brains prefer efficiency. So what does this actually mean for us? Well, it suggests that our languages are shaped by a tug of war. On one side, you have the mechanical constraints of our physical bodies. On the other side, you have the pressure to keep sounds distinct so we can communicate effectively. The fact that the difference in length is consistent but varies in its exact size between people and languages tells us that it is not purely automatic. The researchers also looked at whether speaking faster or slower changed the results. They found that while speaking rate makes these differences shift around, there is no magic switch that proves speakers are deliberately doing this for every word. It is more like a constant background hum of efficiency and clarity. One really cool part of this study was their manual validation process. They literally spent hours double-checking thousands of vowel sounds to make sure their computers were not just hallucinating patterns in the static. This study is a great example of why we should appreciate the complexity of speech. It is easy to think that talking is just something we do without thinking, but every syllable is the result of thousands of tiny muscles firing in a sequence that is influenced by both our biology and our need for social connection. Of course, the study has its limits. They did not factor in every single prosodic rule or local dialect quirk in every language. There might be exceptions hidden in the rhythms of languages they did not dive into yet. The coolest thing for me is the realization that we are living organisms that bridge the gap between hard physics and social intention. Our mouths are constrained like any other physical object, but our brains are constantly massaging those constraints to make sure our messages land. If you want to dive deeper into how our brains and bodies shape our communication, check out the link in the description for their full dataset. I want to know what you think. Do you think we choose to speak clearly, or are we just slaves to our own jaw muscles? Leave a comment below because I love reading your takes on this stuff. If you enjoyed this journey into the lab, hit that like button and make sure to subscribe to RUBIN'S Mind Lab. We have plenty more investigations coming your way and you definitely do not want to miss out. See you in the next one.